Hi, really well done with your pressure and area calculations and pressure under the water, and hopefully you'll all realise that the depth is directly proportional to the pressure as you go down underwater. And when you sit on the bottom of a swimming pool, if you blow out a bubble of air, it changes its volume as it gets towards the surface and it gets larger and larger. Today we're going to move on and talk about the elastic spring constant for different things and the elastic limit. I've got two separate hairbands here. There's a thin one, which is really quite stretchy, and there's a thick one, which is not quite so stretchy. So they have different spring constant. Now, I was stuck at home, and I thought I would order some springs online just to do this. So I've got 150 assorted different springs, and I got one out of the packet, and I said to my handy helpers, I've got some handy helpers there, I'm very lucky, do you think this little spring here could have a whole 1 kilogram masses, so this was full up of masses, could I hang them all on there, and it could go back to its original size?
No, it can't.
Well, she didn't think it could, and she's quite right. It went past its elastic limit and it ended up looking a bit like that. In order to do a proper scientific experiment to find the spring constant, there's a core practical to do this, and we'll have a go at doing one now. So if you'd like to have a look at my very scientific experiment over here, I have some different springs set up on my Chinese takeaway chopstick, I think, and I'm really lucky. I have some different masses, but you don't have to have masses. We had a hammer on there earlier, and I've got some various masses. So I've got different springs with different stiffnesses. So this one is really stiff. It takes a lot of force to pull that one. But this one here, this teeny tiny one that's gone past this elastic limit, I can pull it really easily, and now it definitely won't go back, so they have different spring constants. I used this spring first on the end here, and I put on my zero mass. So I've got my ruler, and I put it so it was at the top. Oh no. No, it's all right, don't worry, I've got my lolly stick, very important lolly stick. So the first thing I did was I measured its length with zero force acting on the lolly stick, and it was 4 centimetres. I did myself a lovely results table like this. So with zero mass and zero weight, it has zero extension. But then I added 100 grams, and I put it on there. I would very carefully use my lolly stick to go across to where the bottom was, and I could see that it was about 5 centimetres. Now, really importantly, when I'm putting down the extension, I need to write 1.0 in there, because actually it was 4 centimetres to start with, and it's only got 1 centimetre longer. And I did that with all of my masses. I put 200 on, 200 grams, and I did exactly the same thing again. I put my lollipop stick across to make sure it was nice. It's about 5.7. So I could put 1.7 on there, because I had to take 4 away. Ideally, I would do it with a clamp stand and clamp my ruler so that the bottom of the spring was at the start, so I just measure off the extension. But unfortunately, I don't have anything like that at home. So I carried on, and I put my masses on all the way down to 1 kilogram. Now I put the masses on, and I did the mass in grams. Ideally, we want the force going downwards to change it into the weight. So it's a force pulling the spring downwards, and then we wanted to measure the extension. So I did it in grams. So first we have to divide by 1,000 to get it into kilograms. So that's 0.1 of a kilogram. And then to get your mass into weight, you times it by 10, the Earth's gravitational field strength. So I did that, and luckily, each one of these, 100 grams, is 1 newton. So mine is really lovely and easy. My weight goes up all the way to 10, and my mass is 20 with 100. You do not have to have masses. You can do this at home. You can do it with anything. You don't have to order some springs online. You can get a pen. If you've got a clicky pen, you can take it out, and every clicky spring has a spring inside. You can hang something on that and have a go at it. Very light things would be better. This little rabbit would be really good to hang off there. We always have to have a rabbit. Now, I massed my rabbit earlier, and the rabbit was 19 grams. And then if I was to put the rabbit onto my spring, I just use the safety pin at the top there. Don't worry, I massed the rabbit and the safety pin. There we are. And then I could measure the extension with my lollipop stick going along there. And that's little Floppy. I put her at the bottom. And then it doesn't matter if you don't have things that are equally spaced. I've got a mummy floppy. She's also got significantly bigger paws than little floppy because she's going to create less pressure on the floor. Luckily, when I massed them, mummy floppy was 190 grams, so she's 10 times more massive. So when I hang her on the same spring, should the extension be 10 times as much, do you think?
Yes.
Definitely, thank you very much, because she's 10 times bigger, and that's when we have linear extension. Right.
Ooh.
So, if you have a look at today's lesson, it's about the spring constant. You have to put whatever date it is of June that you happen to be doing this. We're talking about linear elastic distortion, and the equation is F equals K times X.